Okay, so here we have our next topic, rate of change. And the disclaimer, this video is for the integrated math students from the Nevis Sixth Form College. They have this handout and they will be following along. Okay, rate of change. dy dx means the rate at which y changes as x changes, whether it be increasing or decreasing. When solving problems involving rate of change, there are some steps that we can follow. First, we identify all the variables. We state any rates that are given. We identify what needs to be found, and then we form a connection between the three variables. Let's just start with an example. It says, the side x of a square piece of metal increases at a rate of 0.1 centimeter per second when it is heated. As a result, the area also increases, but at what rate? Okay, so basically, we have a square piece of metal, and we know that if we apply heat to metals, they expand. Now it says this side of the metal square is x, which means that, well, all the sides are x because it's a square. Now, when it is heated, it says that each side increases at a rate of 0.1 centimeter per second. So basically, for every second that passes, the sides are increasing by 0.1 centimeter. So if all the sides are increasing, then the overall square is going to get larger, making the area larger. So that's what the question is asking. While the sides are increasing, at what rate is the area increasing? Now, following the steps, it says identify all variables. So if we go to the question, we see here that the side x is increasing at a rate of 0.1 centimeter per second. So we can express that as dx dt, meaning the rate at which the side changes as time passes, 0.1 centimeter per second. Then we are going to identify what needs to be found, which is the rate at which the area increases, which will be expressed as dA dt. So here we have a formula that will help us to determine that dA dt, which is dA dx times dx dt, and this is from the chain rule. Now, we already have dx dt from the question, so we need to find this dA dx. Now, this is found from differentiating the area function. So, since it's a square, and the area of a square is length times width, we will get x times x, which is x squared. So here we have the area function, which is x squared. Therefore, when we differentiate it, we get dA dx equals 2x. So now we have our dA dx to plug in this location, and our dx dt was given as 0.1. So that's why from our formula, dA dt will be dA dx, which is 2x, times dx dt, which is 0.1. And multiplying them gives us an answer, 0.2x centimeter squared per second. Now, this is a general solution that we can use for any length. So, for example, if the length of the side was 8 centimeter, we can plug an 8 right here, multiply it by the 0.2 to get 1.6 centimeters squared per second. Let's look at a second example. It says, the side of a square is increasing at a rate of 5 centimeters per second. So this 5 is our dx dt. Find the rate of increase of the area. So once again, we're finding dA dt. And it says to do that when the sides reach a length of 10 centimeters. So remember, x is the length of the side. We want to find find that rate of increase of area when x is equal to 10, as you see here. So from the formula that we obtained above, same formula we're going to use, dA dt equals dA dx times dx dt. dA dx is once again 2x because we're still dealing with a square. So when we have the area function of the square, it was x squared and gave us a 2x after being differentiated. dx dt in the question is 5. So that's why 2x times 5 gives us 10x. Now, we want to find it when the area, when the length is 10 centimeters. So we will simply plug x equals 10, and when multiplied, it gives us an answer of 100 centimeters squared per second. Let's look at 2 questions. So it says the side of a square is increasing at a rate of 3 centimeters per second. So that's our dx dt, 3 centimeters per second. Find the rate of increase of the area. We're finding dA dt when the side x is 4 centimeters. So this is similar to the previous example. So once again, we have our formula. dA dt equals dA dx times dx dt. dA dx is once again 2x because we're dealing with a square, and that's from differentiating the x squared. dx dt was given as 3, so when we multiply them, we get 6x. In the question, the length of the side is 4 centimeters, so we substitute the x with a 4, giving us an answer of 24 centimeters squared per second. In this second question, it says, the area of a square is increasing at a rate of 7 centimeters squared per second. So here we're given is dA dt equals 7. They want us to find the rate of increase of the length. So now we're finding dx dt when the area is 121 centimeters squared. So if we go back to the original formula, we can rearrange it or transpose it for dx dt, which we need to find. So this dx dt will be equal to dA dt divided by dA dx. So because this dA dx that was being multiplied will cross the equal sign and get divided. So we have our formula, dx dt equals dA dt divided by dA dx. Now, dA dx is once again 2x because it's a square. dA dt was given as 7, so that's why we have 7 over 2x. Now we need to substitute the value of x, but we weren't given the length of the side. What we were given was the area, and the area is 121. We know the formula for the area was x squared, so what I did was equate x squared to 121 and then solve for x. To get rid of the square, we find the square root and we do it to each side. So when we find the square root of 121, we get our value to be 11 centimeters. So the length of the side is 11 centimeters. So now we can substitute this 11 in place of the x, giving us an answer of 7 over 22 centimeters per second. In this third example, we're not dealing with a square anymore. What we're dealing with is a sphere or a three-dimensional circle. So let's go to the question. It says, a spherical balloon is inflated at a rate of 3 centimeters cubed per second. Now the thing is, the units will help us they will guide us as to what the expressions or the rates will be. So we have centimeter cube, which is the unit for volume, and second, which is the unit for time. So this 3 is the rate at which the volume increases. So that is dV dt is equal to 3 centimeter cube per second. It wants us to find the rate of increase of the radius. We're going to let r be the symbol for radius. So we're finding dr dt. And we are doing that when when the radius reaches 2 centimeters. So that's when r is equal to 2. So here we're dealing with a sphere, and the formula for the volume of a sphere is 4 over 3 pi r cubed. When this equation gets differentiated, we get a dv dr because the function is v and the variable is r. So we get a dv dr equals 4 pi r squared, because 3 times 4 over 3 is 4. We write back the constant and subtract 1 from the power. So that's why we have 4 pi r squared. So this here is the formula that we're going to use to help us find dr dt. So dv dt was given as 3. dv dr we found to be 4 pi r squared. So here we're finding dr dt. So when we rearrange it, our dr dt is going to be dv dt divided by dv dr. So that's how we get 3 over the 4 pi r squared. And when we can now substitute the value of the radius, which was given as 2 centimeter, and that's how we get 3 over 4 pi, and 2 squared is 4, giving us an answer of 4 times 4, 16. So dr dt is now 3 over 16 pi centimeter per second. Okay, so now we are going to look at a question with that sphere. It says the volume of a sphere is increasing at a rate of 12 pi centimeter cubed per second. So that dv dt is 12 pi. Find the rate of increase of the radius. So we're finding dr dt when this radius is 6 centimeter. So this was the formula we had to find our dv dt. So for our dr dt, once more, it's going to be dv dt divided by dv dr, as you see here. So now let's plug in the values. So the dv dt was given as 12 pi, and dv dr is 4 pi r squared. We did that in the previous question where we differentiated the v formula to get 4 pi r squared. So that's our dv dt over dv dr. So when we simplify, these pi's will cancel, and 4 into 3 is 12. So, forgive me, 4 into 12 is 3. So we now have 3 over r squared left back. And the value of r was given as 6. So that's why when we substitute the value of r, 6 squared is 36, and 3 over 36 simplified is 1 over 12 centimeter per second. Now we have an exercise that follows. What we're going to do is the last 3 questions. The top 3 are similar to examples that we did, so we're going to focus on the last 3 questions. So number 4 says, the volume of a cube is increasing at a rate of 18 cm cubed per second. So that is dv dt equals 18 cm cubed per second. Find the rate of increase of the length of a side. So we're finding dx dt when the volume is 125 cm cubed. So to find dx dt, we transpose and we get it to be dv dt divided by dv dx. Now we were given the dv dt to be 18, so we need to now find dv dx. Now we're not dealing with a square or a sphere anymore. We're dealing with a cube. So a cube has equal sides. So the formula for the volume of a cube is x times x times x, which will give us x cubed. And when that function is differentiated, we get dv dx to be 3x squared. So this 3x squared will get substituted in this position. So that's all we have. dv dt is 18 over dv dx, which is 3x squared. Simplified, 3 into 18 is 6, so we have left a 6 over x squared. Now, in the question, we weren't given the length of the side. We weren't given x. What we were given was the volume. So now if I equate that to 125, the volume, which is x cubed, to 125, we can solve for x by finding the cube root of each side. And the cube root of 125 is 5. So this is the length of the side of the cube. So if x is 5, when we square that, we have an answer of 6/25 centimeter per second. Number 5 says, the radius of a circle is increasing at a rate of 1/5 centimeter per second. So this 1/5 is dr dt. They want us to find the rate of increase of the circumference, and we're going to express that as dc dt. So we were given dr dt as 1/5, and we need to find dc dt. To find it, the formula will be dc dr times dr dt. So let me explain to you why this is the formula. We need to find a dc dt. We were given a dr dt, and the only way to get that dc dt is to multiply it by a dc dr, because by normal multiplication these dr's will cancel, and when we do that we'll be left with the dc dt. So that being said, let's plug some values in. So here we have dr dt, which is 1/5. Now this is in the wrong position. Let me erase that. So the dr dt is 1/5, so we need the dc dr. Now the formula for the circumference of a circle is 2 pi r. So when that gets differentiated, we get dc dr to be 2 pi, because pi here is a constant and this r is a variable, so it gets dropped. So dc dr is 2 pi, and when it gets multiplied by the 1/5, we get 2 pi over 5, which is the same as 2/5 pi centimeter per second. For the last question, it says, a circular ink blot spreads at a rate of 1/3 centimeters squared per second. Now, if we look at the unit, this centimeter squared is area. So this 1/3 will be dA dt. Wants us to find the rate of increase in the circumference. So we're finding the c dt when the radius is 1/2 centimeter. Now, we were given the ADT to be 1/3 centimeter per second, centimeter squared per second, and we need to find the CDT. Now, the formula to do that is going to be the CDR multiplied by the RDT. But if you look, we don't have neither of these variables. So, we're going to need our dCdr and dRdt to get multiplied. So here we have some side work. It's a circle and its area is increasing. So the area of a circle is pi r squared. And when that gets differentiated, we get dAdr to be 2 pi r. The circumference of a circle is 2 pi r, and when that gets differentiated, we get dCdr to be 2 pi. Now, from the formula, let me write dA dt is equal to dA dr times dr dt. Okay, we need to find dr dt to plug here, and that will be dA dt divided by dA dr. Now, another way of doing that is backing up, we need to find dCdr and dRdt. Now, from our formula of dA dt equals dA dr times dRdt, we can transpose, and the r dt becomes dAdt divided by dAdr. Now our dAdt was given as 1 over 3. And if we divide by dAdr, which we found to be 2 pi r, we need to multiply by the reciprocal. As you see here, we turn it around. So it's 1 over 3 times 1 over 2 pi r, which gives us 1 over 6 pi r. So we have our dr dt down, and our dc/dr we also found as 2 pi. So now we can multiply to get 2 pi over 6 pi r, and they will get cancelled. The 2 pi will cancel, into itself goes 1 time, and into the 6 pi 3 times. So that's why we have 1 over 3r. Now r in the question was given as half. So when we plug the half in, we get 1 all over 3 over 2, and we can simply upturn it to get 2 over 3. And that's our answer for the CDT in centimeter per second.